Hello everyone. So we are going to start the next unit from the pharmaceutical engineering. So here we are going to discuss the distillation, the process of distillation. What are the basic concepts behind the process of distillation? How the distillation can be done in a pharmaceutical unit setup, and the different equipments which are used for the process of distillation. So without wasting any time, let's start. So in the introduction, let us first have a basic idea regarding the distillation. Here I am going to give you three distinct definitions for the distillation. The first one is that the distillation can be defined as a unit operation which involves the separation of vaporizable component. Now what is vaporizable component? Anything which upon providing heat get vaporized or it get volatile. These are the vaporizable components. So the first definition, it states that the distillation is a unit operation which involves the separation of vaporizable component, means those components which are vaporizable in nature, from a multi-component system. Means that system will have many components. Suppose we have a system, suppose we have a fluid which is a mixture of 2-3 different types of other fluids. Suppose we have a fluid X. Now X is composed of, suppose, 4 different types of liquid A, liquid B, liquid C, liquid D. Now the thing is that we want to separate the liquid A from liquid B, liquid C and liquid D. But the thing is that if we want to separate the liquid A, then the first and foremost thing is that it should be vaporizable. That is, it should be volatile in nature, right? And after the separation, means in the distillation we are going to provide the heat, right? It is going to vaporize. After the separation, the volatile component or the vapor, it needs to be condensed. It needs to be condensed, or the subsequent condensation of the vapor need to be done. This is the classic definition of the process of distillation. Moreover, distillation can be also defined as a process of separating the component substances from a liquid mixture. As I have already told you, we have a mixture, suppose liquid X, which is made up of, or which is composed of liquid A, liquid B, liquid C and liquid D. Now if we want to separate these from each other, then the separating the component substance from a liquid mixture by selective evaporation and condensation. So what do you mean by selective evaporation and condensation? This means that in that mixture of the liquid, we have 4 types of liquid, right? A, B, C and D. The first and foremost thing that you need to keep in your mind is that the boiling point of those liquid need to be different. If the liquid A is having the same boiling point with that of the liquid B, then it is very hard to separate them, right? So for selective separation or selective evaporation, they need to have a different boiling point, right? And the third definition of the distillation is that it is the separation of the component of a liquid mixture by process involving vaporization and subsequent condensation at another place. So condensation at another place means, first of all, we need to heat up the mixture. Suppose that is the X, we need to heat up the mixture X. Then once we have heated the mixture X, different components A will volatile, means get vaporized at a different temperature, B will vaporize at a different temperature, C will vaporize at a different temperature, and subsequently they will get vaporize at different temperature. Now their selective condensation can be done at different places, just taking up the vapor from the equipment. That's it. Okay. Now the application of the distillation, where it is used in the pharmaceutical unit operation. First of all, you see, separation of volatile oils. So volatile oils, these are very much essential and useful in the therapeutic remedies. And these volatile oils, most of these volatile oils, they are generally absorbed or they are generally obtained from the crude herbal drug. For example, if we want to separate the volatile oil from cloves, the cloves, they generally have the volatile oil which have eugenol around 70 to 90%, moreover it have vanillin and acetyl eugenol. The separation of these three components can be easily done by the use of distillation. Next, we have the separation of drugs obtained from plant and animal sources. It is done by use of distillation. For example, vitamin A separation from the fish liver oil. If you want to separate the vitamin A from fish liver oil, that can be done throughout by using the distillation method. Next is the purification of the organic solvent. It is done. For example, absolute alcohol, we know that the absolute alcohol, it has 100% of ethanol, right? So for preparation of or purification of organic solvent, we need to perform the distillation. For example, is preparation of absolute alcohol. Next, purification of drugs obtained from chemical process. There are different types of drugs which are obtained from the chemical synthesis, right? So for their purification of those components, because along with the drug molecule we may have defined other chemical entity which might get produced during that chemical reaction. So separation of those unnecessary or unuseful component can be done by using the process of distillation. Next is the manufacture of official preparation. For example, spirit of nitrous ether, spirit of ammonia, distilled water or water for injection which are used. These are generally prepared by using the process of distillation. Then your quality control methods like alcohol content in elixir, right? We all know that alcohol content in elixir is 4 to 40%. So in quality control test, distillation process is performed to check the alcohol content in the elixir. Then refining of the petroleum product, it is a very classic example of distillation, selective distillation. We have all studied this thing in our school level chemistry, right? How the petroleum, it is graded or it is distilled in different levels, where we get the gasoline, diesel, kerosene, paraffin, etc., right? Next, recovery of solvent. So solvent which are used in the process of chemical preparation of medicine or drug, that can be easily recovered by the use of the process distillation. So now let's have some basic idea regarding some of the terms which will be used further in this discussion. First of all, a binary mixture. What is a binary mixture? Simple two liquids, suppose A and B, there are two liquids. If we mix these two liquids and they are miscible with each other in all proportions, such miscible liquids are known as binary mixture. For example, we have taken water and alcohol. Suppose we have taken 90 ml of alcohol and we have added 10 ml of water, it will get miscible, right? If we take 90 ml of water and add 10 ml of alcohol, it will get miscible. If we add 50 ml of water and 50 ml of alcohol, it will get miscible. Means binary mixture are those mixture or those liquid, or these are those components which are formed when two liquids are mixed together, and these liquids can be mixed in any proportion or in all proportion. For example, we have ethanol plus water, acetone plus water, benzene plus carbon tetrachloride. These are the example. Ethanol and water can be mixed in any proportion. Acetone and water can be mixed in any proportion. Benzene and carbon tetrachloride can be mixed in any proportion. Next is that ideal solution or perfect solution. So what is a perfect solution? See, as per the definition, ideal solution are those solutions in which there is no change in the properties of the component other than dilution when they are mixed to form a solution. I repeat, ideal solution are those solutions which don't change in their property except mixing. Suppose I have one liquid A and the liquid B. Suppose upon mixing liquid A with liquid B, there is no change takes place other than dilution. They will just, liquid A will just mix with liquid B, but there will be no change in their properties of the components, right? This is known as the ideal solution. So what are the properties of the ideal solution? This is a very important thing from the examination point of view. So first of all, you see the total volume of the solution is equal to the sum of the volume of each component in ideal solution. Suppose I have taken 10 ml of A, I have taken 20 ml of B. What should be the total volume? The total volume should be 30, right? So for ideal solution, the total volume is always equal to the sum of the individual volume of the liquid which we have added, right? Next, no heat is absorbed nor it is evolved in the process of mixing. Suppose I have mixed liquid A with liquid B, no heat will be absorbed, moreover no heat will be evolved. Next property, no chemical reaction takes place between A and B. They will just simply mix with one another, right? So the final volume of the solution, it represents additive property. Additive property, as I already told you, liquid A 10 ml, liquid B 20 ml, total is 30 ml, right? So the final volume of the solution, it represents the additive property of the individual component. Moreover, they follow the Raoult's law. Sorry, this should be law. I have mistaken. This is Raoult's law, LAW. I repeat this. This is law, LAW. Don't mistake it. This is my typing mistake. This is Raoult's law, LAW. Now, the next thing, it is the real solution. So what is a real solution? So as per definition, most systems show varying degree of deviation from the Raoult's law. Now the thing is that what is Raoult's law, right? We are going to discuss the Raoult's law in the next slide, don't worry. So most of the system, they show varying degree of deviation from the Raoult's law, means they don't follow the Raoult's law depending on the nature of the liquid and temperature. These solutions are known as the real solution. Means simple, by definition, real solution are those solutions which don't follow the Raoult's law, rather they deviate from the properties or the rules of the Raoult's law. So property of a real solution. In the real solution, first of all, the heat may be absorbed during the mixing of two liquid A with liquid B, or it may be evolved. Next is that chemical reaction may take place between the liquid A and liquid B. Moreover, the final solution of this, or you can say the final volume of the solution, it represents additive property of the individual component. Yes, again I say, if we have added 10 ml of A along with 20 ml of B, the total volume may be 30 ml. But the thing is that in the ideal solution, what we have not get any amount of the heat evolve or absorb, but in the real solution, a little amount of the heat will be absorbed or it will be evolved. Moreover, chemical reaction will be taking place between this component of the liquid. So moreover, this real solution, they also don't follow the Raoult's law. Again, I have made the mistake. This is LAW. So example of real solution: carbon tetrachloride plus cyclohexane, chloroform plus acetone. This is the example of real solution. The next concept is volatility. So what do you mean by volatility? Simple thing is that the volatility of any substance in a solution. Suppose I have any substance X, right? The volatility of any substance in a solution. Suppose I have mixed this X in a liquid A, suppose. It may be defined as the equilibrium partial pressure of the substance in the vapor phase. Means equilibrium partial pressure of what? X in vapor phase divided by mole fraction of the substance in the solution. For example, let's get it very clear. Suppose, for example, a substance A is a substance, right? In a liquid mixer, it has a partial pressure of PA, right? And its concentration in the mixer is XA on the mole fraction. So how you are going to define the volatility? Simple. Volatility of the component A is equal to partial pressure of component A divided by mole fraction XA of A in the solution. That is written as VA. Volatility of A is equal to PA divided by XA. PA it is the partial vapor pressure of A, XA it is the mole fraction of A, right? So the volatility of a material in the pure state, you should remember this, the volatility of a material in the pure state is equal to the vapor pressure of the material. Means suppose we want to get the volatility of any substance A. If it is in the pure state, then the volatility of A is equal to the vapor pressure of A. Simple. The volatility of a material in its pure state is always equal to the vapor pressure of the material, right? Moreover, the next term it is relative volatility. Simple. If here only A is present, suppose one more component was present, B, then what will happen? If we compare A, volatility of A in comparison with B, then this is the relative volatility. So consider a liquid mixture containing two components, suppose A and B. In such case, the volatility of one component is expressed in terms of the second component. How it is expressed? Simple. Relative volatility. Here we have two components, A and B. So relative volatility is equal to, generally it is defined by relative volatility, it is designated with alpha, the sign alpha. So relative volatility is equal to volatility of component A, that is the VA, here we have got VA, divided by volatility of component B, that is VB. So this is the relative volatility. Relative volatility can be measured only when there are two different substances present in the same liquid. Clear? So that's all from this part. Thank you everyone for your patience hearing. If you like the video, just press the like icon. You can share this video with your classmates and colleagues, and for further notification from this channel, you can subscribe my channel. Thank you once again.